The first important theorem related to tangents of a circle is the tangent is perpendicular to the radius through the point of contact. Let me write that for you. The tangent is perpendicular to the radius through the point of contact, POC. Okay, so let me explain this first and then I'll show you the proof of this theorem. Say I have a circle and say this is the point where I need to draw the tangent, and say this is my tangent which is touching the circle at point A. This is the center, and if I'll draw the radius at point A, then this will be perpendicular to the tangent. This is what this theorem says. Say I have a tangent here, and if I draw radius at this point, then this will be perpendicular to the tangent, right? So I think the theorem is clear to you, that what the theorem says. Now let us see the proof of this theorem. See, there is nothing such mathematical about this proof. It is basically related to your understanding, right? So what we'll do, we'll draw a circle first. This is my center O, and this is point A where I need to draw the tangent, and this is my tangent. Okay, so this is my radius at point A. Now I don't know that whether this is perpendicular or not. I need to prove. So what I'll do, okay, so let me say that, let us assume that OA is not perpendicular to tangent, right? We assume that, okay, fine, let us assume that OA is not perpendicular to tangent. Let us say the tangent is L. Okay, so there might be some other line that might be perpendicular tangent drawn from the point O, right? Say I am drawing a line something like this, such that this is OA dash, right? And let OA dash be perpendicular to tangent. Let us see, because here we assume that OA is not perpendicular, so there might be some another point that I can draw, another line that I can draw from O to the line L, such that it is perpendicular to the tangent. So let us say that this is line OA dash which is perpendicular. But what do you actually, when, like, can you just think of the scenario when the line is perpendicular? If I say that, if I have a point here and if I have a line something like this, right, I know what do you mean by the shortest distance of a line, of a point from the line. If I say that this is the shortest distance, it means the perpendicular distance of the point from the line, right? Agree? I won't say this is perpendicular because this is not the shortest distance. Rather, this point, this, say this is B, this is O. OB is the shortest distance. Why OB is the shortest distance? Because OB is perpendicular to the line L, right? So we will use this concept here. Now see, OA dash and OA. If I'll ask you which of them is greater, obviously your answer should be OA dash. Why? Because OA dash, say this point where the line OA dash is cutting the circle, say this is C. OA dash is nothing but OC plus CA dash, right? OC is equal to the radius of a circle, so that is equal to OA. So this becomes OA plus CA dash. So obviously this will be greater than OA. So it means that OA dash is not the shortest distance, hence it cannot be perpendicular. So what is the shortest possible distance of O from A? That is equal to the radius of the circle. And since it is the shortest possible distance, so it has to be perpendicular to the tangent, right? Because you take any other case, say if I have a line like this is not shortest, so it cannot be perpendicular. The shortest distance of O and A is OA, which is equal to the radius of the circle, and since this is the shortest, the distance cannot be lesser than this, so it will be always perpendicular to the point of contact. That is what the theorem says. Now in the previous video there was a thing that we studied, that there is only one tangent at a point on the circle. That is true. Now see why I told you that we'll be seeing the proof of that later, because see, say I have a tangent here, and from this point there is only one possibility that the radius, this line OA, is perpendicular to the line L. I cannot draw any other line at point A and say that OA is perpendicular to, say this is line M. There is only one such line possible such that the radius will be perpendicular to that line. Hence, through any one point, only one tangent can be drawn. Right? So now I think that this theorem is pretty clear to you that the tangent is perpendicular to the radius through the point of contact.